Okay, now we are going to talk about how to measure simple harmonic motion. Buraya açtık ama making sure how to measure simple harmonic motion section. This section is not so much detailed. In fact, compared to the first sections, is less detailed. So first, we are going to learn how to calculate it, how to calculate simple harmonic motion. The first quantity is amplitude. In fact, we know amplitude from Chapter 3, Section 3 also. What is amplitude? As the system is vibrating, system object can move from unstretched position, which we say equilibrium position, on the right or on the left. The maximum distance the object moves from equilibrium position, maximum distance away from equilibrium position, that length is called as the amplitude. Yani, the maximum displacement from equilibrium position is called amplitude and represented by A. And this, for mass spring system, this amplitude is length. Yani, how much is the distance from equilibrium until the maximum, the farthest point from the equilibrium position? This length is amplitude. We can measure amplitude on the right. Also, we can measure the amplitude on the left. But for simple pendulum, amplitude is a bit different. Because in simple pendulum, displacement is measured by not length, by angle. So again, we are going to measure displacement from equilibrium position in equilibrium position, the vertical line. From this vertical line, how much angle away this pendulum can swing? It is amplitude. Again, it can swing on the right, and also it can swing on the left. Yani, this is amplitude. If I write by capital A, this is also amplitude, but it is measured by angle. Next one is one cycle. What is one cycle? Swinging from maximum displacement on one side to the maximum displacement on another side and back again. This is called one cycle. One cycle. Circle cycle, similar. Circle, yani you start from one point, go to the same point, you complete a circle. A cycle. Start where you start, turn back to that position. One cycle is this. In one cycle, object turns back when it started vibrating. That's why net displacement, but linear one. Linear displacement is 0. So, linear displacement is 0, but what is the distance traveled by the object? Give a number to the amplitude. Say that amplitude is 5 centimeters. But 5 centimeters, not only on the left is also 5 centimeters. So now count. One cycle, how many centimeters you travel? From positive A to 0, 5. One forward again, back, 5. And again 5. 5, 5, 5, 5. Yeah. Amplitude plus amplitude plus amplitude, amplitude, which becomes 4 amplitude. Yeah, in one cycle, an object travels a distance which is equal to 4 amplitude. Or, think oppositely, if an object vibrates and travels a distance 4A, it completes one cycle. You can also think opposite way. So, this is one cycle. Half cycle is half of course, the full cycle. From positive A to negative A, half cycle. Or from negative A to positive A, half cycle. And what is the distance traveled by the object? This is 1A amplitude, another A, 2A. So distance traveled is 2A. And then think oppositely. If an object vibrates, and as it is vibrating travels a distance which is equal to 2A, it completes half cycle. You can think this way. But displacement is not, we are sure about what happens. It can be 2A to the right. If it's negative A to positive A, 2A to the right. Or 0 also possible if the object starts from here. So A plus A to A. Yani, displacement of a vibrating object in half cycle can be from 0 until to a maximum to a minimum 0. Between 0 and 2A it can change, depending on from where object starts to vibrate. If it starts from vibrate positive A or negative A, displacement can be 2A. But if object starts from equilibrium, after half cycle, net displacement is 0. That's why I said that it can change between two values, displacement between 0 and 2A displacement. Quarter cycle. Quarter cycle. What is quarter cycle? Half of half. So this is one cycle. This is half cycle. Half of half is quarter cycle. What is distance traveled? One amplitude. Or think oppositely, if an object travels a distance which is one amplitude, how many cycles it completes? A quarter cycle. What about displacement? Longest displacement can be 4, but minimum, pardon, not for you, A. Longest displacement can be A, but smallest displacement, again 0. If object starts from here, say that A over 2 plus A over 2, total is 1A, yani quarter cycle. Net displacement is what? Again 0. Yani for quarter cycle, this displacement can change between 0 and A. For half cycle, 0 and 2A. For full cycle, displacement. Full cycle, 0. Object always turns back where it starts to vibrate. Come on. This is all about the cycle. Now period. Period is time. It measures time for one complete cycle. Yani when object starts from positive A, goes to negative A, back to positive A, you are going to count what is the time for this. It is period. In one period, object travels a distance which is equal to 4A. Time for one cycle is the same thing. And if I say in one cycle object travels a distance 4A, or in one period object travels a distance 4A, because time for one cycle is, yeah, period. You can give the sentence in different way like this. And after the time of one period, object is back where? Like one cycle. After one cycle, it turns back where it started. After one period of time, it turns back where it started. Then, what if time for half cycle? Time for half cycle. It's going to be half of the period, of course. Time for one cycle, T. Time for half cycle, T over. Time for quarter cycle, T over 4. And if more than one vibration is given to us, because it's not easy to measure time for one cycle if the system is vibrating so fast. That's why we calculate total time for several vibrations. After that, we are using this equation for calculating period. For example, 10 vibrations takes how many seconds, which is total time, divided by this total time. How many vibrations or how many cycles are there? We are going to divide them. You will find what is the period of the vibration, because for this vibrating systems, if they are even vibrating faster, it's impossible to measure one cycle if it's vibrating so fast. That's why we measure so many vibrations, total time, then divide by number of vibrations, number of cycles, we calculate the how many seconds is the period. Total time divided by number of cycles, total time divided by number of vibrations. And frequency, opposite of period. Period measures total time divided by number of cycles. Yani time for one cycle measures time. But frequency, opposite. It measures number of cycles, but in 1 second. In 1 second, how much this system vibrates, any system vibrates. That's why their calculations are opposite. Number of cycles divided by total time. Period, total time divided by number of cycles. So its unit is 1/2, because in here, number of cycles is without the number, just divided by time. 1/2. Sometimes we represent by -1, or hertz is the unit of frequency. And frequency and period are inversely proportional because of their definitions. Period is total time divided by number of cycles. Frequency, number of cycles divided by total time. When you multiply, the result is always for any vibration. It's also included waves. Period and frequency are inversely proportional. Yani F is equal to 1/T, or T is equal to 1/F. And now we are going to study everything in general. Yani for any vibration, it doesn't matter if this vibration is mass spring system vibration, or if this vibration is simple pendulum vibration, or this vibration is any other vibrations. We define cycles, amplitude, period, frequency. These definitions never change. But now, from now on, we are going to study 2 specific systems. One of them is the simple pendulum, the other one is mass spring system. Then we are going to write an equation for a simple pendulum, and we are going to write an equation for a mass spring system. First, simple pendulum has a mass m, length of the pendulum is L, and amplitude of the vibration is theta, free fall acceleration at this region is g. Which one affects the period? Now we are going to talk about this. First, length. If I increase the length, is there a change in the distance this pendulum travels? Shorter pendulum travels a shorter distance, this is the arc length. When it gets longer, arc length gets longer. But restoring force and acceleration, same. Restoring force Fg sine theta, acceleration G sine theta. So accelerations are same. But distance is longer when length gets longer. Okay, longer distance travel, a longer time, of course. Yani as length increases, period increases absolutely. Second fact is the mass. If mass increases, but restoring force increases, however, acceleration is unchanged. G sine theta. So how quickly vibration occurs depends on acceleration. If mass does not cause a change in acceleration, so they travel with the big mass or small mass the same distance in the same time. Yeah, that's why mass has no effect on acceleration. Amplitude, yes, they do. How? Let's talk about the amplitude case. Theta, amplitude is theta. If amplitude increases, what happens to the arc length? Increases, absolutely increases. When you think only arc length, you can think that it takes longer time to travel compared to smaller amplitude. But one thing is also changing, acceleration, G sine theta. As theta increases, acceleration also increases, yes? Distance gets longer, but the acceleration also gets bigger. Smaller acceleration, shorter arc length. Big acceleration, longer arc length. So they travel at equal time. That's why amplitude has no effect on period of the simple pendulum. And last one is G. G. I will change only G. So think about G now. What causes the system to vibrate? Force. Without force, could it vibrate? So what is this force? Mg sine theta, remember. What is acceleration? What is acceleration? What's the acceleration of this mass? G sine theta. We didn't change, we only changed G. If G increases, acceleration increases. What does it mean? If acceleration increases, it will travel in a shorter time. So what does it mean? If G increases, time of the decreases. Yani period decreases. Yes, it has an effect, but opposite. Yani increasing G causes a big acceleration, and this mass completes in 1 second. A shorter time, period decreases. Greater G increases, period decreases. But length increases, period increases. That's why equation for P is what? 2 pi, yes, as length increases, period increases. But as G increases, period decreases. Root of Lg, 2 pi root of Lg is the equation for calculating the pendulum, simple pendulum's period. Amplitude, is it in the equation? No. Why not? Because amplitude does not affect the period of simple pendulum. Any question about this, Jessica?
Teacher, if gravity increases, acceleration increases.
Yes,
Is it
G sine theta.
faster, or it will be
Sorry?
It will be faster. Than
Yes, it will move faster. On the Earth, for example, pendulums swing faster. When you take the pendulum to the moon is longer. Yani longer travel time, longer period on the moon. Kevin, second pendulum. Okay. Using the equation is not that hard. That's why I will continue with the second pendulum. This is my question. Second pendulum. Any pendulum who completes 1 cycle in 2 seconds is called second pendulum. Because these pendulums are counting the time. They are used for measuring the time. How? In here, this definition is given. A pendulum that moves through its equilibrium position once every 1 second, sometimes called seconds pendulum. Counter. Let me finish, I will tell you. Yani, this pendulum is swinging back and forth. From here to there, it passes 1 second. Yani half cycle, 1 second. Then back, 1 cycle. 1 second, half cycle. Other half cycle, 1 more second. Full cycle, 2 seconds. So what is the period of any seconds pendulum? 2 seconds. That's so simple. What about frequency? 1/2. Yeah, it's going to be 0.5 hertz. As I said, they used in the past as clock. 1, 2, 3, 4. They're counting the seconds. In Turkish, they say this saniyeleri sayan sarkaç. Yani it's counting the seconds. Biraz böyle anlamlı bir şey olmuş. Yani they are using them to measure the time in the past. Right now, of course, they can use such clock, but in the past it was. Each half cycle, 1 second. One more half cycle, 1 more second. Total time, 2 seconds. A time for 1 cycle is 2 seconds. And period of the seconds pendulum is 2 seconds. Bu değişmez. Bunu böyle öğreneceksiniz. If the period is 2, frequency 1/2. Because we know that if t is 2, second frequency 1/t, 1/2 yani 0.5 seconds. That's all. And mass spring system. Period of mass spring system depends on what? We are going to test them one by one. First, I'm going to test mass. Second, I will test the amplitude. Third, spring constant. First, we know that period depends on 2 parameters, in fact, basically. What is distance traveled by the object? Is it short or long? Second one is how fast this system is vibrating. Two things determines the period. Okay, now let's talk about this. Mass. If mass increases, what happens? What is the historic force for mass spring system? Negative K. As you see, negative Kx is not changing with mass. Yeah, if I increase the mass, in fact, I cannot change the historic force. But according to Newton's second law, acceleration changes. So I know that, yes, F is negative Kx, I cannot change this. I have to know this. But second thing, acceleration, I care about acceleration. I can change, acceleration is changing as mass changes because we know acceleration is equal to negative Kx divided by big M means small acceleration. Yeah, it's F over M. F over M. Negative Kx. Yani big mass, small acceleration. Yani if you attach to spring a big, heavier object, this system will start vibrating slowly. Slower vibration means longer time of travel than longer period. If mass increases, period increases. Second factor, let me talk about spring constant. After that, the third one, spring constant. I will change only spring constant. If K increases, force increases. If force increases, acceleration this time increases because mass is the same, we didn't change the same. Yani increasing K increases the acceleration. Big acceleration means vibrating faster. If it's vibrating faster, time is shorter. Yani if K increases, period decreases the effects. Yes, F is equal to negative Kx, absolutely. Increasing amplitude increases restoring force. Absolutely. Acceleration is equal to F over M. Because F increases, acceleration also increases. Yeah, if you increase the amplitude, system will start vibrating faster. But not only speed increases. The distance it should travel also increases. Yani slow pendulum, short distance. Big pendulum, large pendulum, pardon, faster pendulum, long distance. Their time of travels are the same. That's why amplitude does not affect the period of mass spring system. Tekrar söyleyeyim. Smaller amplitude, yes, slower, but Bigger amplitude, faster. Their time of travel for one vibration is same. That's why it has no effect on the period of mass spring system.
Teacher, you have to say T is directly proportional to the square root of
Root,
that.
of course, we should say that according to the equation. Root of. Then your equation must include these two quantities. One of them is mass, the other one is spin constant, as you see it is in here. Greater mass, longer period, greater K, smaller period. Problem solutions, you can do that, but I'm going to talk about this question. After that, I'm going to finish this part. Two mass spring system vibrate with simple harmonic motion. Two mass spring system vibrate with simple harmonic motion. The spin constants of each system are equal, but mass of one of them is twice that of mass of the other. So each system has a greater period. So there are two systems. They have same spin constant, K and K, but masses are not equal. One of them is twice the mass of the other one. Say that this one is M, first one is 2M. Which system has a greater period? Write period equation. 2 pi. This is 2M over K. This one, T2, 2 pi. As you see, if mass increases, period increases. Absolutely. The one which is a greater mass will have a greater period. The one which is a smaller mass will have a smaller period. Clear?